Generation of impulse current. Lightning discharge involve both high voltage impulse and high current impulse on transmission lines. Protective gear like surge diverters have to discharge the lightning currents without damage. Therefore, generation of impulse current waveform of high magnitude find application in test work as well as in basic research on nonlinear resistors, electric arc studies, and also related to electric plasma in high current discharge. First, we shall discuss about how circuits for producing impulse current waveforms. This is the circuit for impulse current generator and waveform for that. How the capacitor is connected. This is a circuit arrangement of capacitors for high impulse current generation. For producing impulse currents of large value, a bank of capacitors connected in parallel and it is discharged to a series RL circuit. Okay, a bank of capacitors connected in parallel which charged from a DC source to a voltage up to 200 kV. R represents the dynamic resistance of the test object and the resistance of the circuit, and the L is an A-code high current inductor, usually a spiral. If the capacitor is charged to a voltage V and discharged when the spark gap is triggered, the current Im will be given by the equation, that is V is equal to R into Im plus L into dim divided by dt plus 1 divided by C integration of 0 to t Im dt. This is the first equation. Taking Laplace for that equation, you will get this V by S is equal to R into Im of S plus Ls Im of S plus 1 divided by Cs Im of S. V divided by S is equal to Im of S R plus Ls plus 1 divided by Cs, close bracket. Take out Im of S from this equation, you will get Im of S is equal to V by S all divided by R plus Ls plus 1 divided by Cs. Im of S is equal to V divided by S. This only we can write it as into 1 divided by R plus Ls plus 1 divided by Cs. Either you can do this, okay, multiply and divided by, no need of multiply and divided by equation above equation by Cs. Okay, you can go directly for this equation, that is you take out, you multiply S for this. Okay, so you'll get Rs plus Ls square plus 1 divided by C. Okay, after getting that equation, you need to take out L common. Okay, from that equation you need to take out L common. So Im of S is equal to V divided by L 1 divided by R divided by L S plus S square plus 1 divided by LC. This is the equation 2. This separate equation they have considered like this: S square plus R divided by L into S plus 1 divided by LC is equal to 0. We need to find out the roots for this. Okay, root of this equation are S1 and S2. They have find B value is A is equal to 1, B is equal to R divided by L, C is equal to 1 divided by LC. Find out the root S1 and S2. S1 and S2 you will get minus R divided by 2L plus R minus square root of R divided by 2L whole square minus 1 divided by LC. There is a formula that minus B plus R minus square root of B square minus 4AC divided by 2A. Okay. The circuit is usually underdamped so that R divided by 2L is less than or equal to 1 divided by LC. So replace this one. Okay, interchange here. So you'll get this equation. Okay, let the real part alpha is equal to R divided by L and omega is equal to square root of 1 divided by LC minus R divided by 2L whole square. Okay, this will be alpha. Okay, this one is real part and this one is imaginary part. Okay, that is omega. the roots can be written as S1 S2 is equal to minus alpha plus or minus j omega. S1 is equal to minus alpha plus j omega. That can be written now as minus, you take out common minus, so alpha minus j omega. For S2 minus alpha minus j omega, take out common minus, so alpha plus j omega. Okay, we need to find out the again a value and b value. You need to write 1 divided by s plus alpha j omega, s plus alpha plus j omega. But we need to separate this equation. Okay, a divided by s plus alpha minus j omega plus b divided by s plus alpha plus j omega. For first case, you need to substitute s is equal to minus alpha minus j omega, so that a will become 0. Okay, this will become 0 and you will get b value. Okay, for next case, you need to substitute the minus alpha plus j omega, so that b will become 0 and you will get the a value. Okay, b. Now substitute minus alpha minus j omega in this equation. Okay, in this equation, so that b is equal to minus 1 divided by 2 j omega you will get. Similarly, if you substitute s is equal to minus alpha plus j omega in this equation, again you will get a is equal to 1 divided by 2 j omega. From equation 2, we know the values of a and b. Substitute. Okay, Im of s is equal to, what is the Im of s equation? What you got? Im of s is equal to v divided by l, a divided by s plus alpha minus j omega plus b divided by s plus alpha plus j omega. Okay, this equation only two roots we got. What we got equation, that is, after finding a and b value, substitute. Okay, 1 divided by 2 j omega, and this value is b value is minus 1 divided by 2 j omega. After substituting, you take out common 2 j omega, so that Im of s is equal to v divided by 2 j omega l, open bracket, 1 divided by s plus alpha minus j omega minus 1 divided by s plus alpha plus j omega. Okay, for this, take inverse Laplace. Okay, e to the power of minus, open bracket, alpha minus j omega, close bracket, t. Okay, s plus a it is. So e to the power of minus a into t. Okay, so a value is alpha minus j omega. So a value is alpha minus j omega into t. Similarly for this also. Okay, minus e to the power of minus alpha plus j omega into t. Okay, if it is like this, alpha minus j omega t, then you need to separate e to the power of minus alpha t into e to the power of j omega t minus e to the power of minus alpha t into e to the power of minus j omega t. Take out common. Okay, if you take out common, e to the power of j omega t minus e to the power of minus j omega t divided by, you will get 2j. Okay, you take out 2j here. For that can be written as sine omega t. Okay, this value is sine omega t. Formula is there, that is e to the power of j omega t minus e to the power of minus j omega t divided by 2. Okay, replace sine omega t. Im is equal to v into e to the power of minus alpha t divided by omega l into sine omega t. Now we need to find out T1 and T2. Differentiating the current Im and equating to 0, we get v by omega l. You differentiate this one. Okay, differentiate this one. E to the power of minus alpha t. This is u and this is v. Okay, first u as it is, v differentiation. V differentiation means you will get cos omega t into v. Okay, and here v will be same as it is, u dash. U dash means differentiation of u, e to the power of minus alpha t into minus alpha. Okay, after differentiating, take out common from this e to the power of minus alpha t, you will get omega cos omega t minus alpha sine omega t is equal to 0. So that e to the power of minus alpha t is never equal to 0, but because omega cos omega t is alpha sine omega t, omega divided by alpha, can omega divided by alpha is equal to sine omega t divided by cos omega t. Omega divided by alpha is equal to tan omega t. Omega t is equal to tan inverse of omega by alpha. If t is equal to t1, what happens? T1 is equal to 1 divided by omega tan inverse of omega divided by alpha. For of the damped oscillatory wave, T2 is equal to pi divided by omega. For that, T2 is equal to pi square root of 1 divided by LC minus R square divided by 4L square. Okay, this is the formulas for generation of impulse current.